A stone is dropped freely from the top of a tower and it reaches the ground in 4 seconds. Calculate the height of the tower. Take acceleration due to gravity g as 10 meters per second square. We are supposed to find the height of the tower. Acceleration due to gravity is 10 meters per second square. The time taken to reach the ground is 4 seconds. So a stone was dropped from the top of a tower and it reached the ground in 4 seconds. Let us calculate the height of the tower. Now let's use this equation h equal to half gt square. Let's substitute the values. H equal to half multiplied by 10 multiplied by 4 square. So that would be 5 multiplied by 16. That is 80 meters. So height of this tower is 80 meters. A pebble is dropped freely in a well from its top. It takes 20 seconds for the pebble to reach the water surface in a well. Taking g equal to 10 meters per second square and speed of sound equal to 330 meters per second, find the depth of the water surface and the time when echo is heard after the pebble is dropped. So this is the well. A pebble was thrown from the top of this well. Okay, let me quickly draw the water surface. A pebble was thrown from the top of this well. It took 20 seconds for the pebble to reach the water surface. G is given, it is 10 meters per second square. T is also given, it is 20 seconds. First, we need to find the depth of the water surface. Now, we will be using this equation h equal to half gt square. So this would be equal to half multiplied by 10 multiplied by 20 square. 2 5s are 10 and this would be 400. So depth of the water surface will be 2000 meters. Now we need to find the time when echo is heard after the pebble is dropped. Time when echo is heard. Okay, so the speed of the sound is given, it is 330 meters per second. The total time consists of the time taken by the pebble to reach the water surface and the time taken by the sound to travel back up to the top of the well. Time taken for the sound to travel up is time taken by the sound to travel up. This would be T sound equal to depth of well. We have calculated depth of water surface 2000 meters divided by the speed of the sound. Okay, so depth 2000 meters divided by speed 330 meters per second. So this would be approximately 6.06 seconds. The total time when echo is heard T total, this would be time taken by the pebble to reach the water surface plus the time taken by the sound to reach up. So T sound. So this would be 20 seconds. This is already given in the statement of the problem plus 6.06 seconds. So total time would be 26.06 seconds. A ball is thrown vertically upwards from the top of the tower with an initial velocity of 19.6 meters per second. So a ball was thrown vertically upwards with an initial velocity of 19.6 meters per second. The ball reaches the ground after 5 seconds. Total time of journey of the ball is 5 seconds. Calculate the height of the tower, the velocity of the ball on reaching the ground. So we need to find the height and the velocity just before the ball touches the ground. Take g equal to 9.8 meters per second square. At the highest point, the velocity would be 0 meters per second. So initial velocity is given, it is 19.6 meters per second. Total time of journey is 5 seconds. Acceleration due to gravity is 9.8 meters per second square. We need to do multiple steps to get our answers. First, we need to find the time to reach maximum height. Time to reach maximum height. Let me call this T1. V equal to U minus GT. V is the final velocity. In this case, it is the velocity at the highest point. U is the initial velocity with which it was thrown. G is acceleration due to gravity. And T1 is the time taken to reach the highest point. Now V is 0. U is the initial velocity. Let me substitute 19.6 minus G. G is 9.8 multiplied by T1. So 9.8 T1 is equal to 19.6. T1 would be equal to 19.6 divided by 9.8. So the time to reach the maximum height T1 is 2 seconds. Okay, now let's find the time to fall back. Okay, so the time to fall back would be 3 seconds. See, total time of journey is 5 seconds. It takes 2 seconds to reach the highest point from A to B. It takes 2 seconds. Okay, now the total time is 5 seconds. So 5 minus these 2 seconds will give us 3 seconds. That will be the time for the ball to reach from the maximum height to the ground from B to C. So let's just write that. Time to fall back. Okay, so time to fall down. So I'll just mention the points B to C. In the previous case, this was A to B. From A to B, it took 2 seconds. This is T1, 2 seconds. Total time is 5 seconds. So this would be, let me call this T2. T2 will be equal to T minus T1. So T2 would be equal to total time of journey, which is 5 seconds, minus time for the ball to reach the maximum height from the top of the tower. So that is 2 seconds. So T2 would be 3 seconds. So time taken by the ball to reach point C from B is T2, and that is 3 seconds. Now let's find the distance covered in 3 seconds. Okay, distance covered in 3 seconds. So we are going to find the distance from point B to point C. Distance covered in 3 seconds. Okay, so from point B to C, what is the distance covered? So let me call this H fall. This would be equal to half G T2 square. Okay, this is T2. T2 is 3 seconds. We just calculated that. Let me substitute the values. So H fall would be equal to half multiplied by 9.8 meters per second square multiplied by 3 square, that is 9. So if you do the calculation, you will find that height H fall, okay, distance covered in 3 seconds. Okay, the ball reached from the highest point to the ground in 3 seconds, and the distance covered will be 44.1 meters. .1 meters. So this is BC. Okay, so this distance B to C is 44.1 meters. Okay, let me just draw it here. This is point A, this is point B, this is point C. Okay, so we have found BC. Okay, we found BC. This is 44.1 meters. Now let's find AB. Okay, then BC minus AB will give us AC, and that is the height of the tower. Okay, so let me just find AB. So this is h max, let's say h max. Okay, in bracket I'm writing AB. So h max is equal to ut1 minus half gt1 square. Now t1 was 2 seconds. T1 was 2 seconds. Okay, so h max would be equal to initial velocity with which the ball was thrown was 19.6 meters per second. T1 in 2 seconds it reached point B. So multiplied by 2 minus half multiplied by 9.8 multiplied by T1 square. Okay, so that is 2 square. So directly I am writing 4. Okay, so this would be 19.6 multiplied by 2 minus 19.6. Okay, so h max A to B distance. Okay, this would be equal to 19.6 meters. Now we can find the height of the tower. Now let's calculate the height of the tower. Now height of the tower is AC. It is BC minus AB. This is equal to BC minus AB. What is BC? BC is H fall, AB is H max. Or directly you can substitute the values. 44.1 meters minus 19.6 meters. This would be equal to 24.5 meters. This is the height of the tower. Now final velocity of the ball on reaching the ground. Okay, so just before it is touching the ground, what is the velocity of the ball? Final velocity, this is equal to gt square. Now in this case we will be considering g is 9.8, it is already given, and t square we need to consider it's not gt, is now let's obtain the height of the tower. Height of the tower will be BC minus AB. From point B to C the distance is 44.1 meters and distance between A to B is 19.6. So BC minus AB gives us AC, which is the height of the tower. AC is the height of the tower. So H fall minus H max. Now on substituting the values, which is 44.1 meters for H fall and 19.6 meters for H max AB. So let's subtract. So 44.1 meters minus 19.6 gives us 24.5 meters. This is the height of the tower. This is our first answer. And the velocity on reaching the ground, okay, velocity of the ball just before it is touching the ground will be equal to gt2. Okay, so g is 9.8 meters per second square. T2 is the time taken by the ball to reach from the highest point to the ground. Okay, and T2 we have calculated before. T2 is 3 seconds. Okay, time taken by the ball to reach from the highest point to the ground, that is 3 seconds. Here it is, T2 is 3 seconds. So on substituting, you will get 9.8 multiplied by 3 equal to 29.4 meters per second. This is the final velocity just before it touches the ground. This is our second answer. Students, you need to remember that whenever the ball is thrown upwards, g is taken as negative, and that's why this equation of motion becomes v equal to u minus gt. When the ball is traveling downwards, we will take g as positive, 9.8 meters per second square. In that case, it becomes v equal to u plus gt. So whenever the ball is traveling upwards, we have considered this as the equation, and when the ball is traveling downwards, we will take g value to be positive, and the equation would become v equal to u plus gt.